Hello, welcome to another episode of the Common Babbler podcast, where we deep dive into a series of conversations about that discusses science pedagogy with a focus on how to effectively communicate science in an undergraduate classroom. I'm Kalyan Chakrabarti. I'm an associate professor of biological science and chemistry at the School of Interwoven Arts and Sciences in Krea University. And our guest today is Professor John Mathew. Professor Mathew is an associate professor at Krea University in History of Sciences. Professor Mathew has two PhD degrees, one in Ecological Sciences from the Old Dominion University in Norfolk, Virginia, and the other in History of Science from Harvard University, Massachusetts. Professor Mathew was also as an associate professor at the Indian Institute of Science Education and Research, IIScr, Pune, before coming to Krea. Welcome, Professor Mathew.
Thank you very much, Professor Chakra.
It's a pleasure to have you here, and I hope you don't mind if I refer to you as John.
I was rather
So,
hoping that you would. So
thank you.
yeah, good.
And I think I should mention here that John is a polymath in the truest
Right.
sense of the word, and you have wide range of interests, and you have very active interest in music and theater. And in fact, probably you were prepping the students for a choir in
Right
the
now,
coming Christmas
today,
today, right?
also yeah. So yeah,
And in the next trimester, I think your course is
science, history, and theatre.
science, history, and theater. Wonderful. Okay. So, what are your hobbies? I mean, beyond work, clearly you have many, many interests. And so, recently, which hobby you are preoccupied with?
Probably music and theatre. And 2 days ago, I finished writing the script for a musical, which we hope to do for Christmas. But with everything going on, including the cyclone, we may not be able to get to do it on the 20th of December. We hope to do it on the 10th of February, if all goes right,
Okay.
thereabouts. But we'll have a trailer on the 20th. And if it happens, it would be exciting because it's the first time we'll ever be doing a musical at Korea. And that should be fun. And so working with the students has been really quite wonderful. Thank you.
Fantastic.
Thank you.
You were working, your research interest is the history of science and also history of pandemic.
Yes,
You have worked on both the Great Plague and the influenza
correct.
pandemic in the 1890s and the second one in
The 19 teens.
19
Teens,
teens.
yes.
Right.
Yeah.
So, what's I mean, so that's already a very interesting background. And what first what motivated you to study the past
Pandemic.
epidemic?
What was interesting for me, and I found this, I mean, it was quite adventitious in some sense. Um, for my PhD in the history of science, I was working on the making of taxonomic zoology in India under the French and the British. And so I set this up as a series of questions. Why would you undertake this task? Who was undertaking the task? Do things change when theoretical frames get renewed in some sense? And it is, or altered. So so one of the questions I asked was is when I was looking at the series, the Fauna of British India, where you have 81 and a half volumes. Strangely, there was a half volume in Mammoth. Um, was whether when germ theory began to rule the roost, and if you think about it, in the first 10 years of the Nobels,
Mhm.
um, for the life sciences, right? Half go to immunology and germ theory.
Right.
And then that is, and it just speaks about just how prominent this was and what this meant in terms of a very different way of exploring and understanding disease.
Mhm.
So, as a zoologist, this interested me because the question was, is it that now there would be an inflection? Is it that the books of the fauna of British India would start to concentrate disproportionately upon vector biology, for
Mhm.
example. Now that you know that Ronald Ross, for example, who was working in India,
Right.
has has shown what the vector is in many ways, and in other colonial areas. Laverin is doing this in Algeria. And so it's just, and you're saying, well, so you've got the colonies, or at least for empire, which become these crucibles of experimentation.
Right.
And so I asked that question. So that's how it arose.
Right.
But what I found eventually is no, that didn't become the case for the fauna of British India. That's largely, I realized later, as a function of who's doing the work. And you say, fine, if these are people who are taxonomists and only know how to study moths, then yes, all hell might be breaking loose somewhere else. But
Right.
heck, I know moths, you know what I mean? So that is that. But, and it was only later by about people like Southbourne, like where you would find concentration on, say, the mosquitoes. Or, But this was not necessarily the case in other areas. The Bombay Natural History Society, which had come into being in the 1880s, was having, I mean, in its journal, had articles on the plague, for example, and rats and the collecting of rats. So there were other venues, other vehicles in print that were doing this. And when you look at the Indian Science Congress, which had a venerable past, I only wish that continued, but you had significant people speak, like Leonard Rogers, for example, speaking about the spread of cholera, for
Right.
example, and these are very early in the 19 teens, and so I'm really interested in how these feed off each other
Right.
in the history of medicine and the history of science, history of biology. And I think that's from where it arose in many ways. And then I said, okay, now that you've got this, how is this informing us? Because a mosquito or a rat is just as much animal as anything else, right? So the zoological story becomes interesting. In the First World War, there were other questions. Look at parasitology. And you say, fine, are snails the vectors for parasites? Is there a greater propensity for them to essentially latch on to, or at least release the parasites in ways where there's human action? And so there are two areas that became interesting. One is germ theory, bacteria, and only bacteria early, right? And microparasites we consider malaria.
Right.
And parasites, so think about guinea worm and the like.
Right.
And they're using words like filtrable virus. And all the things, it's something that's smaller than a bacteria.
Right.
But what's interesting, and I think with the influenza, is it would still, people like Lakshman of Leishmaniasis, for example, is writing about the bacteriology of influenza. And it's only Richard Sharp in the 1930s that will show that it's a virus. And so what I find really fascinating as doing the history of science is how people are trying to make sense based upon their knowledge at a particular point in time of what X or Y might be as a phenomenon, which is why science continues to be such an exciting area of study in that sense. I hope that helps.
So I will circle back to it. So there's a lot to unpack, I think. But I just wanted to know that so you were working on a book
On the fauna of British India.
to fashion a fauna for British India.
Yes, although the name is now changed.
Okay.
And it's now Writing Zoological Natural History for British India. So there's a history to this. The OUP, Oxford University Press, India, agreed to use the thesis title that I had at Harvard. And
Okay.
they said, fine. So I said, yes. And then they closed shop in many ways, and they transferred it to Oxford University Press, UK.
Okay.
And they were less accepting of the title I had. So now I'm stuck with this in some sense. It tells a story, but it loses the elegance in some
Right.
sense. But there you are. I mean, but that's what it is at the moment, yeah.
But what is it? Is it focusing on what you just described?
It is in many ways. And so one of the key elements, and it's an interesting story. Well, way back when I was doing my second PhD in 2004, I went to Koshi's in Bangalore,
Right.
where which you probably know.
Yes.
and spoke to one of our colleagues, now colleagues over here, Ramachandra Guha.
Okay.
And so I was casting around for a project, and I said, I can do one of two things. I was very inspired by his and Gargill's book, which is the first major tome on environmental, well, ecological history in India, which is called Disfigured Land, which
Okay.
appeared in 1992. And over there they talk about this point of animus between the agricultural secretary wants to survey, I mean, keep forests, right, and take them away from the local use.
Right.
And at that time, ironically, the person in charge is A.O. Hume, who will later go on to help found the Indian National Congress,
Okay.
right? So there's this, but he's this strong joiner of the say, versus the Madras government, who's saying, should we give more rights to people? So that was one angle that I want to consider, which is spoken about. And the other one was the series of books that I knew as an undergraduate
Right.
in the Madras Christian College called the Fauna of British India series,
Okay.
and which honestly, for the uninitiated, and I continue halfway to be there, is dry as heck,
Right.
right? Because you just go in there and you're seeing description after description after description.
Right.
But years later, I said, why were these books ever written? And so I put this to Ram and I said, I've got these two projects. He said the ecological one is largely done. I would recommend the second option. So I ran with that and I said, fine, let me look at the history of the making of these books.
Right.
Then I realized, and this is a circuitous path, as PhDs often are, that in order to cast light upon the story, I would need to start a century earlier.
Right.
And that is where the first works in British India would come into being.
Right.
And so, for example, people like Patrick Russell, after whom the Russell's viper is named, working on the snakes and the fish of southern India, around Madras, for example, or Francis Buchanan Hamilton working up in Bengal. Like the other really key determination, and that's for me one of the most exciting parts of the work, and is that at the turn to the 19th century, the people who really knew the most in a Western sense, I mean, of epistemology, and I won't use the word scientific yet because that word enters the lexicon only in 1842, a scientist, right?
Okay.
But are the French.
Right.
The French are way ahead of the English, and in fact, there is this, and I show this sometimes in some of my lectures. There was in 1816 something known as Le Journal de Physique et Chimie et l'Histoire Naturelle, which translates into the Journal of Physics, Chemistry, and Natural History, right? So the terms that are being used in the 18th century are natural philosophy and natural history. We know this, we taught SCR together.
Right.
But what is interesting is that in the July of 1816, you're having the word natural history, which is an omnibus term, and by the January of 1817, it is being divided into botany, zoology, geology, and there's this, and that is, and you're seeing the genesis in some sense of disciplines the way we understand them now. Zoology had been used in the past for materia medica, for medicines that are derived from plant animal products.
Right.
But now these are much more in terms of taxonomy.
Okay.
So that story is something that I traced, and then through the 19th century, I would look at which are the groups that are studied. And I set this up as a thought experiment, which I use and I continue using in my book. I said, in case you have in a colony under thrall, right, and you say, fine, it's all the way from, say, 8 degrees north to go up to about 23, 24 up there, and you're trying to make sense of it from and produce knowledge.
Right.
And if you're applying this to animals, I mean, I'm kind of looking at animals, you can talk about plants as well. How would you go about the task?
Right.
Would you look at all animal groups in a small area? Or by contrast, would you look at one group across a much larger area? So you say
Right.
the birds of India versus the fauna of Pulicat, for
Right.
example. And that is,
Right.
and the answer is that both happen as a function of who was doing the work. I mean, there would be government functionaries. In a large contingent were Scottish doctors, and that's because they had a mandatory paper in natural history, which the English didn't have.
Right.
And so there are differences even within Great Britain,
Right.
and so that's interesting. So a lot, and this would have major implications in India because one chap who was English but studied in Scotland, a person called Jerdan, would go on in Thomas Caverhill Jerdan, T.C. Jerdan, would go on to write The Birds of India and The Mammals of India. And he was a surgeon in Madras and then moved on to other places. He was apparently an inept doctor,
Okay.
but a very good naturalist in many ways. And so these things happen.
Balanced out.
Balanced out in many ways, yeah. So there's him. The other question, of course, is who else is doing work? And there are people who were working in England who had never set eyes on India.
Right.
But they were getting collections being
Right.
sent, right? And so they were working on that. And so one of the major social tensions, in some sense, is people over here who are saying, what do people sitting in Britain know?
Right.
We have seen, we know it. And so the whole question of locality versus studying at a distance really becomes important in this particular question. And those are some of the resonances that appear in the book. Another major question that arises is, where are the Indians?
Right.
And so that's and a couple of my chapters deal with people who could have been potential contributors in many ways and yet perhaps had other preoccupations, which is why when you start seeing a more consistent presence of Indians,
Right.
it's only in the 20th century.
Really.
And that is, and you start wondering what the Indian medical service starts taking covenanted members, that's the top level, in the Indian medical service, but the person called Surju Kumar Gudeev Chakrabarti. And so, yeah, they have said, yeah, he's who's come from Bangladesh, and I mean, what is now Bangladesh, but
Right.
East Bengal, and he came second overall,
Right.
but he had to take the exam in England.
Right.
And so, and he got the prize at the University of London, now University College London, for comparative anatomy. And he was working with people like Robert Grant, the person who introduces the name porifera for the sponges, right?
Okay.
But he also taught Darwin in Edinburgh before coming down south and was the first teacher of zoology anywhere in England. Right. At UCL, I mean, now UCL, rather than Oxford or Cambridge. So you think about potential candidates who could have done this, and then afterwards, why it didn't happen, So those become some of the questions that emerge. So that's how it largely is, right? The fact is, you're saying, what are discoveries to be made? And these are the fun ones in many ways.
I suppose you probably get this question a lot. So if we now take a step back and ask that should there be a history of science for undergraduate students now, right? And how would you answer that?
Absolutely. And I think both a history and a philosophy of science are key. And dare I say, even a sociology of science. One of my moments of forced epiphany was when I sat in a class taught by Sheila Jasanow, Sheila San Jasanow, in the Kennedy School of Government at Harvard. And I was, in many ways, the work I had done on the phylogeny and conservation of a group of carnivorous caterpillars, which is for my first PhD, which I worked also at Harvard, although I got my degree from OU Dominion, but I worked for 5 years in the laboratory of Naomi Pierce, was that in some sense I was black boxing things. And so she said, okay, does it mean that there's an essence to science? Or, and I've come around to this point of view, science is like any other, a social construction with its conventions,
Right.
and there is and you need an acceptance of those conventions in order to produce
Right.
everything to a journal. Now, this is not unique to science. It's true also in the humanities and social sciences, in
Right.
literature, and all of these.
Right.
Now, that was important for me to see. right? Because then you start asking questions as who an expert is.
Right.
So, for example, one of the questions you have when you talk about taxonomic zoology, you're sitting in England, and
Right.
people say, but do you have first-hand knowledge of this?
Right.
Right? And you're saying, fine, I've got this from Zambia, this from the Congo, this from St. Vincent in the Caribbean, this from India. Let's put them and say there are these slight differences. And the one very amusing situation was a person called G.A. Boulanger who wrote The Reptiles in Batrachia for the Fauna British India, and there was a scathing response. So I said, Mr. Boulanger we are advised, is very equipped to do this work, but he does not ever appear to have been in India. The work suffers on just that particular account. For example, he tells us that Draco ducimere has forewings that are flattened with wings. But nowhere does it say that Dracons fly. Was Mr. Boulanger unaware of the fact, or did he think it too trivial to mention? So it's scathing, right? And so and I think there's a danger of losing those stories. I think, for me, the whole point, and this is one of the fears about a straight line story of science. It does not talk about the parts that were foreclosed.
Right.
And if you do, and if they do, it's typically to lampoon people.
Right.
For example, I think that Jean-Baptiste Lamarck gets a much worse reputation than he deserves.
True.
And
True.
I mean, because he did tremendous work. He's speculating, right?
It's, as they say, that hindsight is 20/20.
20, exactly. You
So
said hindsight.
in retrospect,
yeah.
it's very clear what was right, what was
Wrong.
wrong. It's just that at that moment it was not. Funny thing is, so it might, and then you walked on the you had studied the history of epidemics.
Absolutely.
Does this also change after COVID? That why is history of science important? So now that after in a post-COVID world, what would your answer be if someone says that, okay, what did we learn from studying the history of epidemics that happened hundreds of years ago?
A great deal. I mean, for example, what was it you immediately started saying? Why was it that the United States wanted chloroquine from India, for example, which is an extract of quinine which you were using for malaria, for crying out loud? And you and I worked on this at this point, and we were planning to write, and I still think we should. But I think that as a historian, you say, why would you take, and we asked this question then, why would you take a potential cure, a cure, for a microparasitic disease, i.e., malaria, and apply for a virus? I mean, does this make any sense? But it's also telling that for all of the sophistication, and we saw this, right, when they were doing that Netflix series on COVID. The first one was all very triumphalist. And we said, we should have this in no time at all. And then 2 years elapsed. And so and you didn't even need 2 years to elapse for the third episode to be much more about mental health. And there was this forced humbling in some senses. And the fact that you're looking at potential sources of cure from something from over 150 years ago, when you're still working in India under the terms of the Epidemic Diseases Act, which is enacted in 1897, right? This is still the terms of it, right? You're saying, is the history of science still relevant? Absolutely, blindingly so, right? This is what they're doing, right?
Right. So, and for a little bit of context, I think, so I should add that you have been one of the designers of the course Scientific Reasoning. And clearly, many of us thought that all students should learn some amount of scientific reasoning, irrespective of what they major in later part of their career. And in scientific reasoning, you contributed to the chapter on the London color of 1854.
1849 and 52, 54. So there were these moments, so to speak, yeah.
It was a fantastic example of scientific reasoning in my mind. So And then I think one thing that you mentioned and that kind of stayed with me is that at that time the prevalent theory of cholera was the so-called miasma
Miasma
theory.
theory.
And it was not known that it is waterborne
Mm-hmm.
disease and the miasma or the bad air has to be
Mm.
dispelled. One of the way to dispel it was by smoking tobacco,
They said, yes, in order
right?
to get rid of the noxious effluvia. That's what
So,
see, all of these were considered possibilities.
right,
And if there was a correlation at one moment for one
right,
person, then you extrapolate it for the whole.
right,
With at that time, and this is the interesting thing, and you mentioned this, it was all about questions of sample size, right?
right,
And this is where John Snow becomes really interesting because
right,
he's looking at cases, right?
right,
And he's saying how many cases. And a point that you raise here is significant because you still haven't elucidated germ theory
right.
at this point in time,
Hmm.
right? You're still thinking about the fact that there are two areas. One miasma, and there's something. The other is contagion. You cough on something, and so
Right.
therefore it's considered a direct contact thing. The why
Hmm.
is still up for grabs.
Right.
But Snow, the fact that Snow did his work without recourse to
Hmm.
germ theory
Hmm.
is all the more remarkable.
Right.
So he's saying, because what he's doing is he's saying, fine, why is it that people in this part of North London,
Right.
yeah, are demonstrating the disease? He already had. So he what he's doing is this is interesting. You had different companies
Hmm.
taking charge of different parts of the city.
For
And so you
supplying water.
supplying water. Well,
Hmm.
the same thing was true for cemeteries. You had
Right.
the London Cemetery Company in Highgate, you had the General Cemetery Company. So it's across the board, right?
Interesting trivia.
So yeah, it's true. Yeah. So you had in where they were, they had what they had found was there were two companies. I mean, you had the Lambeth Company,
Okay.
and the Southwark and Vauxhall Company. And the argument was that the Lambeth Company had slightly purer water in terms of their treatment than the Southwark and Vauxhall Company.
Hmm.
But what they're finding is that in North London,
Hmm.
as things stand, there was a mixing of these two. So
Right.
therefore, that was the other question. Of course, was who was being affected,
Right.
and so he went street by street,
Hmm.
looked at case studies, fatalities, even
Right.
morbidities, right? And he's saying,
Right.
fine, and what is happening? He found that in a particular place by a particular pub,
Right.
not as much. And that's because eventually they were drinking a lot more
Right.
other than water. You know what I mean?
Right.
So if ever you want to make a case for the pub, there's one
Exactly.
for you. But and then he was able to say that outside on a particular street called Broad Street,
Right.
there was a pump, right? And it's the question of what was upstream and downstream of that pump,
Right.
right? And very close to it, the sewage was
Hmm.
going directly there. And so what he could say was these are the people that are likely to be affected, and here are the number of cases. And so he was able to demarcate with an excellent case of mapping
Right.
and case study. So as I said, as opposed to a sample size of 2 or 3 or 10, here he's sedulous in the use of statistics, right?
Right.
In many ways. And so you can see how numbers become absolutely crucial to what will become the discipline of epidemiology,
Right.
right? And I think that is and that's remarkable work. I mean, he dies in his 40s. I mean, but you can imagine how this
Right.
young doctor, right, in many ways, is doing this work. I mean, I still think of it as utterly remarkable.
It's really fascinating.
Mhm.
Another thing that I think of is that, and again, kind of comparing with development of other sciences. So, for example, the science historian Thomas Kuhn famously refers to the paradigm shifting science, and then otherwise something that is more regular or incremental science.
Mm.
In biology, do you think that this epidemics kind of shifts the paradigm because there was the regular biological research about the molecular aspects and building a more coherent picture, and then suddenly something like COVID comes
Mm.
and everything is disrupted.
I think even before the molecular turn, I think just the elucidation of germ theory itself
Right.
becomes a game changer.
Right.
Now, so there are two things I'd say over here. And I was giving a talk actually for SCI recently, and it was and they asked to speak about why history matters for
Right.
science, right? And one of the arguments that's been made, and I'll come back to your point a bit, but is was there a revolution?
Right.
And so one of the arguments that's been made is a scientific revolution differs from, say, a political revolution. For example, if you had the French Revolution between 1789 and 1793, you
Right.
have something happening. You don't have that with science, right?
Right.
You didn't, or even the Industrial Revolution. You know, there's a moment from the late 18th century into, say, the 1820s and 30s, what's the moment, and the full flourish coming in the 50s and 60s, and everything moves from there, so that's its inexorable turn. Whereas if you think about developments in science, because science is so omnibus in many ways, David Button speaks about it. He says that for me, the scientific revolution happened with the astronomical revolution, right?
Okay.
So therefore, he will say, so you're looking at people like Copernicus, Kepler. So you're talking about this as a largely 16th century phenomenon. Okay. The physiological revolution will occur in the 17th century. You think about Harvey and the circulation of blood.
Right.
The chemical revolution will occur in the 18th century, where the argument is that the 1740s were probably closer to the beginning of the AD period than between 1740 and 1780. Because what's happening around from 1770 to 1780s is the discovery of oxygen. And you've got, for example, Carl Wilhelm Scheele, you've got Joseph Priestley, you've got Antoine Laurent Lavoisier, and all doing this. The very fact that you're saying phlogiston no longer occurs, right? You say, what do you mean by phlogiston? You can come up with an explanatory form that no longer needs phlogiston, right?
Right.
And that ushers in a whole different way of thinking about chemistry. And then in short order, you will have people like Faraday and Humphrey Davy and all that in the Royal Institution and Dalton. And it's extraordinary that
Right.
both physics and chemistry coming in. If you come to the 19th century, you have what you will call the Darwinian revolution, right?
Right.
And that becomes its own game changer. If you come to the turn from the 19th to the 20th century, you have germ theory becoming this major change. By the time you come to the 40s and the 50s, you have the molecular turn,
Right.
and that changes. So the question is, which of these is a scientific revolution? You've just gone through 5 centuries, right? And then you can come to the 20th, 21st century. You've got the digital revolution, right? So I don't. So it's a hard one. So you can see how it can be argued in both cases. Are these all discrete elements? Are they a case of different scientific revolutions? What do you need? The other point, which Kuhn makes, I'm coming back to Kuhn, is that he says the term in incremental science, it's called what he calls normal science.
Normal
right?
science,
Yes,
right.
So he's saying so normal science happens within a paradigm.
Right.
And so you can do excellent work, but you're extending that paradigm.
Right.
Then, when the data cease to fit or don't fit as well, you say, is there another explanatory framework? And that's when you have a paradigmatic shift, or the paradigm shift, as he calls it. And when that happens, it becomes almost, I mean, to use a statistical idea, like a paired t-test, a before and after, right? And you have this moment in them, and the two are incommensurable. And that's the word that he uses, that if you use the one, you can no longer depend upon the other, right? And you can no longer use the other. Now, the question is this necessarily true? When Einstein came in, you've got the Einsteinian revolution as well, with, relativity, I forgot. So that's 1905, 1916. And so is that, and then quantum theory, but like you can keep talking about things. But the point is, did Kuhn make too much of it? And first of all, his examples were largely from the physical sciences.
Right, I was about to
So
come there.
that-
So
okay.
basically, this whole relativity and
Yeah.
quantum revolution are kind of the basis for Kuhn's.
Yeah, in mathematics, it's very, so it's biology is very little in it, right? And even there, because Einstein has come in, it's not like you've thrown out Newton.
Right.
And so the question, I don't know whether the whole notion of incommensurability necessarily holds in toto, but I think it's a useful heuristic,
Right.
To say, fine, if you think about something that's changed, a revolution has its own sense of setting down markers at the very left. So,
Mm.
I mean, let me give you another example. Does the Anthropocene exist? For this point of time, is it
Right.
coterminous with the Holocene?
Right.
When will you place it? At the top of the 18th century, after the Second World War? When do things start changing? And you can see just like where's that golden spike in some
Right.
senses, and so therefore that's something we're dealing with right now. Is that a moment of revolution? So, from a geostratigraphic perspective.
I think while discussing in scientific reasoning, I think you made an interesting point that some point the discussion was about what is science. And I think it's Popper's description that something that is
Falsification.
falsification is an important part. Where do you stand on that? Should
It's
you?
a hard one. I think in some senses it's also the strange hierarchy.
Right.
We call the caste system in science, if you will. So if our mathematics and physics right at the very top. Of course, someone
Right.
can also argue that mathematics is an art,
Right.
right? Because you come with very elegant explanations and theoreticals, but do they have a practical analog, right? In some sense, physics does.
Right.
But then the whole notion of what are the exact sciences? So is that falsifiable? You might say yes, because you've done things to find out, and you would expect that this would occur. Is that necessarily true for what you call les sciences en plein air, the sciences in plein air, the field sciences, for example? What happens if, can you guarantee that external circumstances are always going to be the same, right? So therefore, when you have that, how do you replicate? For example, you go out and you say, okay, it's cold. This is the climate right now. What are you going to do, right? And I think to that end, falsification is useful but limited, and limited by the nature of the work you're trying to do. Now, even with biology, how many people can you interview? What happens now with subject consent and things like that? Is it easier to work with mice than with human beings? Which group are you working with? What's an adequate sample size? What do you do? So, and there's no way you can say that this can be equivalent or equal. Again, I come back to the whole notion of a social construct. It's a consensus that you're saying this suffices.
So that's interesting that what you called as a social construct. I think that's also I don't know if many people might have more of an absolute view of science.
That is the problem, right? Yeah.
You're right. So, and also, I don't know if social construct. I think at some point you also kind of made a point that one can also see science as a like a social contract.
It is in many ways. The laboratory is a social contract, and this goes. And there's a brilliant book in this regard, which is written 1985, called Leviathan and the Air Pump, and it looks at the 17th century. And there are two people. One, the philosopher Hobbes, Thomas Hobbes, who writes this book called Leviathan. At the same time, you've got Robert Boyle, if you know pressure volume temperature, of Boyle's Law, who's a member of the Royal Society, and he's produced the air pump. He's looking at the whole notion of a vacuum, right? And how you're trying to create a vacuum. And so the question is, to whom should knowledge accrue? Should it, when you're doing work of this particular kind, I mean, and which will now perhaps retrospectively be called the closest to science that you could get, does that become a conversation for the very few, for the select, the laboratory? Is it an arcane group of people? Or does it belong to the wider populace? It looks as though the laboratory system is won out in some senses. And now, of course, with intense competition and the like, the notion of secrecy has become a great deal. But that was a construct. If you think about how it developed, what is the genesis of any of these? And I would be hard pressed to find scientists who are able to mount a robust defense of saying, well, no, there's something essential to all of this. How? I mean, everything from the point of view of the construction of your vernier calipers to your burettes to your pipettes, all of these, they're being made to particular specifications. They're emerging from a trial and error process. But, so I don't know. I think think about what Jenner did, for example, with cowpox and smallpox. It's you're figuring things out. It does not, for me, it does not diminish the wonder and the power of science. And I don't think science is any the less if scientists
Mm.
had the humility
Right.
to accept that what they're doing is a social activity as much as any other.
Is it fair to say that science is too important to be left only to scientists?
Absolutely. Think about, and I think a movie like Oppenheimer will tell you that, right?
Right.
I mean, it demonstrates the
Right.
case
Right.
hugely, right?
Right.
So,
You have taught previously at Harvard, the University of
mm-hmm.
Massachusetts, and
You,
Duke. So, and you have taught extensively in India also, in
with
like
ISA, yeah.
IISc, Pune, and here.
Mm-hmm.
What would you like to see changes in science teaching, science pedagogy, if you were to design the syllabus, and what would you do differently?
It depends for which of the sciences. And I think, I mean, I admit that for me, so much more comes from the sciences in play now. You've gone out bird watching with me, so you
Right,
know
right,
what that, or butterfly watching and the thing. I do think that, at least for biology, there should be a great deal consistently of seeing things out in the
right.
organismic aspect of it. And I've given you, I may have given you this, told you the story elsewhere before. But when I was working in the laboratory of Naomi Pierce at Harvard, she was working on this group of butterflies that belonged to the family Lycaenidae.
Mm-hmm.
That's the same group with which Nabokov worked, for example. I mean,
Okay.
who wrote Lolita and all that. But
Right.
he's writing in the night, but during the day he's going catching butterflies, and
Oh,
and he comes up with this wonderful, now validated story of how you've got some of the butterflies may have come through the over the Bering Strait through Alaska and down, and in a group called the polyomatines, and now it's been shown to be correct. So here's again talking about a polymath. There you've got one, right? I mean, this tremendous worker who's showing this, and he's writing these controversial but gloriously eloquent books in many ways. But
it's a
so,
little disturbing now that I think about
but
it.
yeah, that puts you off. But anyway, oh well. But he's and for all of that, an extremely faithful husband. Just goes to show. But anyway, so and he talks about his wife Vera. I think he names a species after her, things like that.
Oh, yeah.
So yeah, I think to that end, it's great to be able to see that level of construction in some sense
Right.
of this. So, and he is out in the field. I would like to see people do that. So I was telling the story. So in Naomi Pierce's lab, there was this when we were doing phylogenetics. There was when you do when you're using this program called phylogenetic analysis using parsimony, one of the
Mm.
models you got parsimony, neighbor joining, Bayesian theorem uses, and so you and there was one and what in many ways your standard of reference was morphology because
Okay.
you're looking at morphology and you might have been using the Adiagas, for example, the what is the male reproductive organs and say are these similar, and what was very often nice was to see where there was concurrence between the morphological data and the molecular data.
Okay.
Say you're using cytochrome oxidase 1, you're using elongation factor 1 alpha, one of which is mitochondrial, the other one's nuclear. And you're
Mm.
saying, so therefore, the mitochondrial one in cytochrome oxidase 1 is going to evolve more quickly than the
Right.
nuclear one, which because it's much deeper. And so you'll tend, and so you're looking for some level of corroboration among molecules over there.
Right.
And then you'll say, fine, will you use mitochondrial data for more tippy groups, for example, at the level of the species,
Mm.
whereas you will use nuclear information more for deeper groups, say at the level of the family
Right.
or genus and the like. So those become interesting questions. It becomes a game after a while because you say, do you upweight or downweight transitions to transversions, for example, and what do you do, right? So there was one particular species
Mm-hmm.
that kept coming out with a group that you didn't expect.
Okay.
So you got all of these convoluted explanations as to why this might be the case.
Right.
Then you got a field biologist called Rod Eastwood who'd come, and they invited him to take a look.
Mm-hmm.
he went and looked at the specimen from which they'd taken this, and they said, "You've got the wrong butterflies." And so
That's
this
a
is
little anticlimactic.
it is anticlimactic, right? But it just gets to show that people who are so caught up in the laboratory and don't have a clue about what's going outside are likely to run into just some kinds of thing. And having seen it, actually,
Yeah.
I mean, it gave me a real new appreciation for people who understand systems outside. And those are conversations that need to be had, which is why now you're looking so much for total evidence,
Right.
which looks at corroborations of morphology and molecular. So I would like for people to be able to see that. I think if you are a biologist, and we've spoken about having potentially different tracks for even in biology, those that want to do molecular versus
Organism.
organismic biology. I do think that there should be for both at least 1 to 2 required courses in the other.
Right.
Just so that you are exposed and you get an appreciation on the ground of what the totality of the story might be. And that's
Nature doesn't care much about how we
how we
split and
exactly.
slice
We
between
don't-
molecular and
exactly. It doesn't give a damn,
knowledge.
right?
So,
But then again, nature doesn't care about political borders either. You know, that's true.
That
Yeah.
is true. Yeah.
So and it just goes to show: do we miss a trick
Right.
by slicing and dicing too much? Right?
Right.
Because
Right.
do we really miss the forest for the trees? And that's something which,
Right.
no pun intended, phylogeny.
Right.
But anyways,
What do you think about the study of history of science in India? Is it, I mean, again, I mean, there must be scope of doing things more?
oh, absolutely. And I think I used to sit on the research council up in Delhi for a
Okay.
while, and it was and the Indian National Science Academy, INSA.
Mhm.
And while there were some thoughtful people there, what was frightening was that the vast majority seemed to be about translations of old Sanskrit works that you're saying, and then it works out to how well you know Sanskrit, and then you're superimposing those ideas upon one science, and you say, well, this is, and you're saying, is this astrological? What does this do? And then and it was also tied in ineluctably
Right.
with the sense of this is ours.
Right.
And so nationalism was coming in, and it seemed to be undergirding all of this. And you weren't getting those many from more recent works and the things that it's as if this is the Western story. Yes, we can do it, but let's keep looking at the 4th, 6th, 11th centuries. And so I don't now those some of those papers might have appeared elsewhere in the Journal of the Royal Asiatic Society, which looks at philology, which looks at things, which looks at astronomy, and that is fine. I mean, it says, but to say that this is being coeval
Right.
with the modern scientific project is concerning.
Mm.
It's what's creeping into. I mean, Ayurveda, and I'm not I'm not being disparaging of Ayurveda, but I think that again, does it meet criteria that will be recognizable in some sense? And then, now, if you say you need to expand this, then that needs to be discussed before it makes it something like this. Unlike the Indian Science Congress recently, where you had entire sessions on it, and you're saying, fine, are you doing something that flies in the face of?
Right.
Now, let's take another example. We take Lysenko, right? This Ukrainian who works.
I was actually thinking about him.
Lysenko.
Yeah.
Yeah, and you say, fine, you've got the whole notion of vernalization, right? And eventually he's responsible for the death of Nikolai Vavilov, right?
Right.
This is, and you're under in the Stalin regime, and there are cautionary stories.
Right.
And this is another reason why the history of science should be studied, because you say, what is it that happened, and why is it that these stories are not foreground? If anything, I would say people who want to do science should have a necessary course on all of these political scientific efforts that came to grief.
Right.
Because you say, so again, a certain humility should be tried. Yeah.
Thank you so much, John, for this fascinating conversation.
Absolutely.
And, thanks for your time. It's
Not at
wonderful.
all. Wonderful.
Yeah.
Thank you, Kurt.
Thank you.
And here's looking forward to more chats along the way. Take
Thank
care.
you.
Thank you for having
And
me.
then, so we'll be back with a new episode of the Common Babbler very soon. Thank you.